Alright, let's pick up pretty much where we left off. This was the last problem we did, but I'd like to move on to a problem that's worded a little bit more like the way you're going to be seeing problems, a more conventional way. Okay, so let's look at this one. Alright, consider the titration of 50 milliliters of 0.2 molar strong acid with 0.1 molar strong base. Calculate the pH at the following points in the titration. Okay, so this is what you should get used to seeing. You're given sort of the initial setup for the problem, but then you're told these different volumes. Okay, so it's actually, let's see, 1, 2, 3, 4, 5, 6, 7 different sets of calculations that you'll need to do. Don't worry, they're not too bad. Okay, so what you're going to need to do for this, actually the first one's fairly straightforward. For the first one, we're assuming that 0 milliliters of the strong base have been added, so the only thing in the solution contributing to the pH is the strong acid. So all you really need to do for that one is take its molarity, take the negative log of it, because that's also going to be the molarity of the H+, and that's going to give you a pH of 0.7. Okay, so that's the first one. See if I can actually write that up here. 0.7. So that's our first answer. Okay, the next question is actually assuming what happens after you take that flask, you open the burette a little bit, and you add to it 10 milliliters of our strong base. Okay, so for this one, we have to do a little bit of stoichiometry before we figure out what our new concentrations are going to be. Okay. And I'm actually going to introduce a new unit, which is the millimole, which sounds a little bit crazy, but it's what you get if you take the milliliters, so we've got our 50 milliliters, and we multiply it by our molarity. That's going to give us our millimoles. The only benefit to this is just that you don't have to do a conversion between moles and, milliliters and liters. We're generally going to be working in milliliters, so it's easier just to work in millimoles. And you'll see that it comes up a couple more times where this is just an easier way of doing it. Okay, so we've got 10 millimoles here. We've got 1 millimole here. And I got that from taking the 10 milliliters up here and multiplying it by our molarity to give us that number, the 1. Okay. Our change, if you look at this, we've got H plus and OH minus. The OH minus is much less, and it's going to be fully consumed by the neutralization reaction. So we're going to wind up with a change of minus that 1, minus that 1. We basically don't care about the water at all. So we're going to have an after here of 9 millimoles and 0 millimoles. Okay. Alright, in order to calculate the H plus concentration, we're going to take the number of millimoles of H plus, which is right here. Okay. And we have a new volume, and that's going to be a theme in many of these problems. There's always going to be a new volume because we've taken 10 milliliters and we've added it to our original 50 milliliters. And we saw that in that last problem that we had done as well. Okay, but it is very important to remember that. Sometimes it's easy to forget. So we're going to have a new volume of 60, okay, which is going to give us a new molarity of 0.15. Calculate our new pH. Our new pH is going to be 0.82. And this actually makes sense because if you look before, we had a pH of 0.07. Let me actually erase some of the stuff we've got going on up here. We had an original pH of 0.07. Now if we've got 0.82, it's gone up a little bit because we've added a little bit more base in, so the pH has moved up that pH scale, but it hasn't changed dramatically because we did start with a strong acid. All right. Let's look at the next one. So this is kind of the framework you can use for all of these problems. So I'm actually just going to erase it here, and we'll add in our new millimoles, our new volumes. Okay, so for this one, we're going to assume 20 milliliters of NaOH will have been added. Okay. We still have the same 50 milliliters and the same 0.2 molar HNO3. So we're still starting off with our 10 millimoles here. Okay. But now because we've got 20 milliliters of our 0.1 molar NaOH, now we've got 2 millimoles here. You could just ignore the water the whole time. Okay. All 2 millimoles are going to be consumed, so we're going to subtract our 2, 1-to-1 ratio. We're going to wind up with 0 and 8. Okay. So if we move down here, now we've got 8 millimoles. We've got a new volume of the 20 plus the 50, so now we've got 70 milliliters. Millimoles over milliliters is going to give us a molarity. That's going to give us 0.11. We'll put that into our equation down here. And we're going to get a new pH of 0.94. I'm going to write that up here. Okay, and you can see that that pH is slowly changing. It's slowly going up, but it's doing so very slowly. Okay. All right, for the next one, for the 50 milliliters, why don't you take a second and try that yourself? You can pause the video if you need to, because I'm going to just kind of keep rolling. Hopefully for that one, you got an answer of 1.3. 1.30 for your pH. All right, for the next one, we have 100 milliliters of the NaOH. And if you look at this, this means that we have 10, our normal 10 millimoles here, but now that we have 100 milliliters of NaOH, and it's 0.1 molar, that means now we've got 10 millimoles of our OH minus. You don't even have to do the calculation to know that because it's a strong acid and a strong base, and we have equal amounts, and it's a neutralization reaction, we're going to have a pH. This is our equivalence point. We're going to have a pH of 7. Okay. So we've reached our equivalence point. So now we've got, let me erase that so I can add that in up there. We've got our pH of 7. So now you can see that we initially had a slow change. Now we've got a dramatic change because we've gotten ourselves to the equivalence point. Okay. And from this point on, we're going to have more base than we have acid. Okay, so if we do the next one, the 150 milliliters, we do still have the 10 millimoles of the H+, okay, for the sake of our calculations. But for the OH minus, now we've got 15 millimoles. Okay? Which means that all of the H+ is now going to be consumed. Okay, so that's going to give us 5 millimoles and 0 over here. So now when we do all of this stuff down here, it's really not an H+. Now it's an OH minus that we're talking about, because that's what we have remaining. So we're going to take our 5 millimoles here. We've got our new volume of 150 plus our original 50, which is going to be 200. So this is going to give us a new concentration of 0.025, which is going to give us a POH. If we put the 0.025 in here, it's a point. Okay, we're going to just take that away from 14 so that our pH is equal to 12.6. Okay, so I'll actually add that in here, 12.6. All right, why don't you do the last one, the 200 milliliters, for yourselves. I'm not even going to tell you the answer. Do that, bring the work and the answer into class when you come in for our next meeting. All right, one more problem that you need to work on in addition to finishing this one is here. Let's go over to it. Okay. So do this problem on your own, bring the work in, let's talk about it when you get into class. Remember that when we talk about adding in 25 milliliters, we're talking about adding in 25 from the starting point. We're not saying 25 on top of the previous. So then when we go to 50, It's not 50 in addition to the 25, it's 50 from 0. It's always based off of an initial 0 milliliters. Okay? So give this problem a try, bring your answer into class, okay? And there's going to be another video that deals with how to answer questions involving a weak electrolyte.